Basic electrical engineering. We had studied different type of insulating materials: solid insulating materials, liquid insulating materials, gaseous insulating materials. In solid insulating material, we are studied about the different type of fibrous material, impregnated material, plastic material, rubber material, mineral materials, ceramics, glass materials, and non-resinous material. Like that, we are having different application related to insulated materials of liquid stage also: mineral oils, synthetic materials, vegetable oils, fluorinated liquids, silicon fluids, vaseline, varnish. And gaseous insulating materials: air, nitrogen, hydrogen, inert gases, halogen, sulfur hexafluoride, carbon dioxide. In our previous video lessons, we have completed the solid state insulating materials of different types. In this video, we are learned about the gaseous insulating material. Gaseous insulating material serves two purposes. Firstly, it acts as an insulation, and secondly, as heat transformer medium. The gases are most commonly used as insulating material because they are cheap and easily available and non-flammable. The dielectric strengths plays an important role in the selection of gaseous insulating material. The dielectric strength of these material increases with increase in gas pressure, hence they operate under pressure in electrical apparatus. The most common used insulating gases are air, nitrogen, hydrogen, inert gases like neon, argon, and sulfur hexafluoride. So our Earth atmosphere is composed of air. Air is a mixture of different gases and contain 78% of nitrogen, 21% of oxygen, and with a small quantity of water vapor, carbon dioxide, argon, and various other components. Air, like other insulating gases, the dielectric constant of the air increases linearly with increasing gas pressure. Air acts as an insulation in many electrical applications, in addition to the solid or liquid insulating material provided. Common examples are overhead transmission line, air condensers, plugs, switches, various electrical machines, and apparatus. Let's see about the hydrogen. Hydrogen is It is rarely used as an insulator. Electrochemical and electrothermal are employed for generation of hydrogen from water. Electrolyte breakdown of water is a source of hydrogen. At normal room temperature and pressure, it is a colorless, odorless, and tasteless when it reacts with oxygen to form water H2O. We all are know about water. Its chemical form is H2O. And hydrogen peroxide is H2O2. We are used in so many applications in hydrogen peroxide also to clean and in first aid treatments, to clean the wounds, small scratches, while if you are playing, if any small scratches or anything occurs on your skin, by using that hydrogen peroxide we first clean that area. After that we go to that first aid treatment, right? So hydrogen relatedly we know two items. One is H2O, water, and another is hydrogen peroxide. Our hydrogen is used for cooling purpose as well as liquid insulating material. What are the properties of the hydrogen? It is very light and can penetrate well into the interior parts. Its density is 7% of that of air. It has high thermal conductivity, means 7 times that of air. Hence, it can dissipate heat at higher rate. Its dielectric strength is 2.5 to 4.5 kV per mm. The liquid hydrogen reduces the resistivity of copper. And this hydrogen is deoxidizing agent, hence reacts with an oxide coating format on surface to form water. It prevents fire accidents. This is most important. Hydrogen prevents fire accidents. It is non-toxic and non-metallic at normal temperature. Most of the hydrogen on earth is in molecules such as water and organic compounds because it readily forms covalent bond with most non-metallic elements. This hydrogen is highly inflammable and burns with blue flame forming water. So these are the different types of properties. So by observing these properties, what are the applications for the hydrogen? The various applications of hydrogens are due to its low density is one of the property, right? Due to its low density, it is used in high speed electrical rotating machines to reduce its windage losses. and it is used for cooling purpose in electrical machines. It is used as a fuel in rocket. Hydrogen is used as fuel, so it is called rocket fuel also. Remember this point. And it is used in the manufacture of fertilizers and filling weather balloons. It is used in the preparation of oxyhydrogen flame. Which is used in welding due to production of high temperature. It is used to prepare tungsten filaments. And transmission lines, air condensers, plugs, switches. Mainly the rotating high speed electrical machines and apparatus all are having the applications related to hydrogen. So this hydrogen is used in high speed electrical rotating machines as well as it is used for cooling purposes in electrical machines also. And sometimes it is used as fuel also. And it is used in the manufacture of fertilizers. Different type of applications. And for weather balloons. Weather balloons gives the climatical condition results. To fill, because of that this hydrogen is having very low density. That's why it is used to fill that weather balloons. It is used to prepare tungsten filaments. Nitrogen. Nitrogen, it is chemically inert. It can be used for both electrical and chemical purposes. It prevents oxidation and thus reduces the rate of deterioration of part of equipment. In many high voltage applications, air is replaced by nitrogen due to this property only, because of it prevent oxidation for the other insulating materials. So what are the properties of nitrogen? First of all, nitrogen is a non-metal. and it prevents oxidation and increases the life of the equipment. It is chemically inert gas. It is used for electrical and chemical purposes. Its dielectric strength is 3 to 5 voltage per mm. So what are the applications? The nitrogen is used as insulator in certain type of capacitors. In conjunction with oil treated paper insulation, it is used in high voltage gas pressure cables. It is used in oil filled transformers to prevent oxidation of the liquid insulator. What is the liquid insulator used in the transformer? Mineral oil. So our nitrogen is used to prevent oxidation of the mineral oil, thereby prevents formation of sludges. It is used as cooling medium in sealed gas insulated transformers. It is used as a safety component in airbags of transport vehicles. See, airbags is there in cars also, parachutes. Every time airbags is there in transport vehicles for safety measurements. There nitrogen itself is used, and nitrous oxide is used in vehicles to increase the power of engine and speed of the vehicles. It is used to prevent oxidation. It present in all living things, including the human body, means our body and plants also. Because of what is the reason? 70%, 78% I think. 78% of air is nitrogen itself. That's why it is present in all living things, including the human beings and plants also. Nitric acid. What is the formula for that? HNO3 and ammonia NH3 are the compounds of nitrogen, which are used in fertilizers. These are used in cultivations. These fertilizers are used in. So these are the applications. It is used as insulators as well as oil treating paper insulation purpose, and oil filled transformers. It prevents oxidation and sludges also, and in addition to this insulating, it gives a cooling medium also, and at the same time it is a safety components in airbags in so many vehicles. The power of engine and speed of the vehicles, nitrous oxide is used to increase that power, and it prevents the oxidation. Why? What is the reason? It always prevents the oxidation. That's why it reduces the rate of deterioration, means increase the life of the equipment. Wherever we want to prevent the oxidation purpose, There we are used the nitrogen. In the previous case we are studied about the hydrogen. It is completely oxidized. It reacts with oxygen to form H2O. And one more time it reacts with oxygen, then it will form H2O2, means hydrogen peroxide. So it is not used for those type of applications. Nitrogen is used such type of application where the prevention of the oxidation is required. 78% of the air itself contains a nitrogen. That's why it lives in all the space, all the human parts, all the plants, animals, everywhere it is there. And in fertilizer industry also, this nitrogen having the application of nitric acid and ammonia. These are the different type of applications related to nitrogen. After that, the next type of air insulating material is SF6, that is sulfur hexafluoride. The sulfur hexafluoride is a very outstanding performance gaseous insulating material. It is an electronegative gas and has a strong tendency to absorb free electrons. When sulfur is burnt in an atmosphere of fluorine, sulfur hexafluoride is formed. Its molecules have octahedral geometry and containing 6 fluorides atoms around sulfur atom. It has many advantages as an insulating gas. So many. Gaseous insulating material. The SF6 is a main gas. It is it is very popular gas insulating material. The dielectric strength increases with increase in pressure. Hence, it must be used under high pressure. So, some sealed tanks, gas cuts, all those are required for construction with the capable of withstanding high pressure. So sulfur hexafluoride, when sulfur is burnt in atmosphere of fluorine, sulfur hexafluoride is formed. So these are the different features what we are saying. After that, what are the properties of this sulfur hexafluoride? Comparative with normal air, what is special in this? That's the thing we have to study. Because of that, our substations are there, right? You all are know about the substations. It is near to your villages or cities, different types of substations, transmission distribution substations. All are overheaded systems, and this substation is just, it is in air, it is in normal atmosphere. That is outdoor substation. In fact, this is a air substation like that. SF6 substation is also there. Due to marvelous features of this SF6, the air is replaced with this SF6. So what is the speciality for this sulfur hexafluoride? Let's study its property, then we are getting a little bit idea about this. After that we will talk about the applications part, right? The following are the properties of sulfur hexafluoride. It has high dielectric strength, about 2 to 3 times that of air. So comparative with air, the dielectric strength of this SF6 is more, and this sulfur hexafluoride is colorless, odorless, non-inflammable and non-toxic gas, and its thermal conductivity is about 2 to 3 times higher than air and has better heat transfer ability. These are the two statements related to comparison between the air and the SF6. Here SF6 gas dielectric strength is more, and at the same time thermal conductivity is also 3 times higher than air. So SF6 has better heat transfer ability, and it has very superior cooling properties to those of air and nitrogen. This is a third point, comparative with air, and it has high degree of chemical stability. At atmosphere pressure and at temperature up to about 100 degrees centigrade. It is an electronegative gas and has a strong tendency to absorb free electrons. But this SF6 is very costly and sold by weight in tanks. Air is free, it's cost less, it's free of cost, but it is costly. SF6 is due to this positive features compared with air, and sold by weight in tanks and transported in liquid form. At normal temperature it is non-corrosive and its density is 5 times higher than air. This SF6 is chemically stable and does not react with structural material up to 500 degrees centigrade. Its properties are affected by moisture. So what are the properties specially observed here? It is non-inflammable and high dielectric strength, and cooling property is very superior to those of air and nitrogen. At increase in pressure, its dielectric strength also increases, may even become equal to that of transformer oil. So these are the specialties related to this sulfur hexafluoride. Dielectric strength is more, non-inflammable, non-toxic, thermal conductivity is also high, superior cooling properties compared to with air and nitrogen, and it is very chemical stable. It is non-corrosive. Those are the positive attributes related to the properties of the SF6. What are the disadvantages? To have high dielectric strength, this gas must be used under high pressure. For this purpose, we need a sealed tank with gaskets, gas tanks construction, like that. then only it's capable of withstanding the pressure over the whole temperature range of its commercial use. So definitely a construction is needed for this purpose to getting this future additional benefit, that is high dielectric strength at high pressure. The presence of sulfur in the molecule under some condition involve corrosion of the contacting surfaces, and sometimes its properties are affected by moisture also, and it is density is also high comparative with the air, and it is completely costly, and sometimes it is affected by moisture also. These are the relative advantages and disadvantages of sulfur hexafluoride. So what are the applications? The sulfur hexafluoride has the following applications. It is used as dielectric in transformer and electrical switches. It is used in circuit breakers also as arc quenching medium. It cools the arc produced between contacts. It is used as insulating medium between live parts of high voltage equipment. SF6 circuit breaker becomes more popular in high voltage engineering. Why? Because of this better arc quenching ability property only. And this sulfur hexafluoride gas is used in medical field also and foundry applications. Aluminium as a trace gas in reduction of porosity, corrosive and toxic. It is used as insulating medium in gas insulated substation. So SF6 gas substations is also very famous. Because of that, those substations make the substation very compact. Our air substation occupies very large place. Because of that, it is some space is required from one equipment to another equipment. Because of that, the insulating medium is only air. That's why live parts are there of high voltage equipment is there. So definitely it needs some large place. But this sulfur hexafluoride is having this feature, right? It is insulating medium between live parts of high voltage equipments. So small space is needed. It is that small space is enough. That's why instead of using this air substation, if we use this SF6, it occupies very less place. Then the substation becomes very compact compared to with this SF6 substations. So overall, which type of applications we already seen about this SF6? It is used as dielectric, and at the same time it is used as a arc quenching medium of a circuit breaker, and it is used as a insulation medium between live parts of very high voltage equipments. This is a main important point. Insulation between high voltage equipment. This feature makes very famous of this SF6 gas. That's why this SF6 gas substations are coming into picture. For this feature only it is very famous in. So these are the special features of our SF6 substation. Also there, due to its compatibility between live parts, there is no much space is needed for this. So SF6 gas insulated substations are very famous. So up to now we are studied about the different type of insulating materials. We covered all the insulating materials: solid state, liquid state, and gaseous state. All those things are having different type of application in our complete electrical engineering applications. Depend upon its properties, we are used this type of different materials at different type of application. This electrical engineering is a vast field. Vast means very big field in which a large number of materials are used for different functions. So have to cover much more type of materials. We studied the conducting materials also. After that, insulating, we have studied different type of insulating materials. On the basis of temperature also, we are studied as class Y, class B, class C, class F, class A, class H, class C type of insulating materials. After that, this solid type, in that natural cotton, fibrous material, that is wood, cardboard, cotton, silk, asbestos, papers, like that materials also we are studied. And impregnated means, for example, if the paper is there, we are giving some treatment to impregnate. This impregnated treatment improve its property than the normal paper, then it is called the impregnated paper. Like that, we process the impregnated fibrous materials also. After that, plastic materials are also we are studied, natural and synthetic plastics. In synthetic, thermosetting and thermoplastic materials are also studied. After that, rubber materials we are studied, natural rubber and synthetic rubber. Depend upon its properties, those materials are used in different type of applications. And mineral materials are also studied. Mica is a mineral material. This mica, the India supplies mica to the world. We are very proud to say. How much percentage it is supplied? 80% of the total world requirement of the mica is supplied in our by our India, and it is found in Nellore and Bihar also. After that, we are studied the ceramic materials and glass materials, non-resinous material. After that, we are move into the liquid insulating material. It has different type of mineral oils, synthetic materials, vegetable oils, fluorinated liquids, silicone fluids, Vaseline and varnishes. All are having its own importances and its own applications. Depend upon their property, we are using different type of applications. Next, we move to the glass insulating material. In that gas, in this present video, how many types are we are studied? We are studied about the air, nitrogen, hydrogen, and sulfur hexafluoride. These are the different gases mainly used as gas insulated substations. In this, SF6 is more famous compared to with air and nitrogen. But this is about the insulating type of materials. After that insulating material, we move to the special purpose materials also. What is a special purpose material? We are using different type of engineering materials related to our electrical engineering field, because of we are having very large number of applications in different functions of different materials. We are used different type of applications in particular functions. So the materials can be broadly classified as primary materials and secondary materials, whereas a material which performs secondary functions are known as secondary materials. The material which performs primary functions are called primary materials. It is often necessary to use certain materials not directly connected with the given function, but to assist in performing the function effectively and efficiently. The secondary materials are also required. For example, filling materials are there. Our natural resins are used for such purposes. It is not directly used, but it is used to give, or it is used to assist the primary function of the remaining equipment. Let's start our special purpose material introduction. Some special materials are required for our special applications. The structural materials like poles and towers do not perform its function as a conductor for transmission and distribution of power, but it supports a complete transmission system. It supports a complete overhead. You all are seeing these poles and towers, all those things in near to our houses, our streets, all are having the different types of poles, concrete poles, RCC, wooden poles like that. It supports what? This type of conductors. So, in electrical engineering, special materials are classified into so many types. Mainly, it is classified as 6 groups. See, what is the purpose of this special material? Here, see, what is the material of use used in this figure? It is an alloy of lead and tin. See, this is the fuse. Up to now, we are studied about this conducting and insulating material. But this tin and lead, it is not a conducting and insulating material. It is a special material but it is hugely required in our electrical engineering. So those type of special purpose materials are coming into picture. So we are studied the conducting and insulating materials, right? It is comes under the primary materials. Because of that, its function, it performs its function directly. The special purpose materials are coming under the section of secondary material. Because of that, the secondary material are used for special purposes. Without the use of secondary material, the primary function would not be effectively and efficiently. It is incomplete. Definitely we require this special purpose material, that is secondary type of material. So what are the different type of categories? Let's see. Structural materials, protective materials, thermocouple materials, bimetallic means thermostats, soldering materials and fuse materials, galvanizing materials, impregnating material, like that so many types of special materials are coming to picture. We already covered a different types in some applications in some of our chapters. In our third unit, thermocouple material are used. Bimetallic materials are also used in electrical kettle, for automatic temperature control, iron box. We are used. Galvanizing and impregnated materials are also used in the insulating materials to improve its properties. Like that, this is not the primary material, it is a supported material which is required to perform its function effectively and efficiently of the primary material. Secondary material means it assists, it gives very assistance to the primary material for its effective functioning. With the help of the special materials or secondary materials, the primary materials complete and finish their task with a effectively and efficient manner. So our next target is what? To study about the special purpose materials. These are the different type of special purpose materials. In detail we have to study in our next video. Thank you, and mostly you follow the same thing in your textbooks also. Okay, in the next section we will discuss about all this type of special purpose material. Just I give the introduction only. So this is a fifth unit, insulating and special purpose. We complete the insulating material part, and in the next section we are going to learn about the special purpose material part. Hope you understand. Thank you, and thank you for watching this.